All right, so we're recording today for a couple reasons. The first thing I want you to do is, you see the warm-up on the board. Let's state the area. State the area of a rectangle. Somebody, anybody. Length times width. What's the area of a square?
Length times width.
Well, okay, yes, but how would we make it unique to a square?
It's basically a side square.
Side squared. Because of the same length. And so we wouldn't use a different letter when they're the same length. I know, that's kind of semantics, but, okay, so you get the idea there. What about a circle?
Pi r squared.
Pi r squared. Okay, that's something we've talked about. All right, so let's take a look. I'm going to take my computer over because I want to show you some of the things that are happening over here. So we're live, we're recording. Make sure we can see it. Okay, yes. All right, so now, talking about prisms. Today, we really only have two objects that we want to discuss, okay? A prism and a cylinder, all right? So here's an example of a cylinder. I'm going to pass this around just so you can put your hands on it, look at it a little bit more. But what's the base of a cylinder?
Circle.
Circle. So if I want to find the volume, well, let me go to a real life scenario. If I want to find the volume of lunch today, which it is, this is my lunch today. If I want to find the volume, I need to find the area of the can by finding the circle, the base of the can, times the height. And then I've got the in total volume. Got it? All right, so that's kind of the lesson for cylinders. Pass that around, please. Okay, what about a prism? Let's go with a very basic prism. This looks like a rectangular prism because the square is different than the height. So it's not a cube. That would be more like this one. You see the difference? Okay? Yeah, just pass it around. I just want you to. All right, now I'm going to pull this out. And now this, we're going to take 2 minutes and talk about what is inside here. Okay? This is what we would call a net. N-E-T. A net. And we can use a net to find, this is one of our standards for the Department of Education in Indiana, to find the surface area. Okay? In this case, the bases are squares, and the lateral faces are rectangles. And there's 4 of them. And so we just find the area of each, add them all together, and we've got the lateral surface area. That's called a net. We don't do a lot of practice with it, but you know it. Okay? Okay, so prism. All right, now let's look at some of the more unique prisms. Here's one. If you look at the base, you can see that it's got 1, 2, 3, 4, 5, 6. What's that called?
Hexagon.
Hexagon. That's right, hexagon. And then each side again is a rectangular.
Rectangle.
So it's a rectangular hexagon right prism. Now I used the new word there, right, meaning that if I would set it flat, it's straight up and down. Okay, so it's a right prism. Okay, so let's go to this funny shaped thing. If you look at that, have you ever driven on 465 around Indy?
No. I've been
Around the northwest side of Indy, there are 3 buildings. Anybody know what they're called? They're called the pyramids. Okay, now they're not exactly in the shape of a pyramid, but they're actually called the pyramids because they do have a similar shape to this. Now, this is not a right pyramid because it's got a unique, you guys see how it's almost like it's leaning? Okay. Anybody know what term that would be used to demonstrate that it's not straight up and down?
slow.
We haven't talked about it. That's a good guess. Slope.
Yeah.
Slanted. It's a good guess. It's a weird word.
Bent.
No, the actual word is called oblique.
Oh, that makes sense.
Oblique.
Okay.
Does it? Okay. All right, one of my favorites. What's this called?
Cone.
It's called a cone. All right, what happened here? Hold on, let me get this. I think Sam, I think you kicked it and it stopped.
Didn't mean to do that.
Yeah, that's still recording. So this is called a cone. Why is this my favorite? You turn it upside down, it has some ice cream. That's right. Now look at the net though out of this. This is pretty cool. Now that's not exact on this one, but take a guess. What shape do you think that this would be on this one? Semicircle. Yeah, it's an exact semicircle, and then a circle as the base. So I'm not sure which day yet, but we are going to have some. We're going to explore and investigate cones. Look at some volume. Fill them up with some creamy substance, with some sugar, chocolate, vanilla. Just investigate it. Make sure that it fits all the way in.
Not strawberry, right?
Only crazy people like strawberries. Okay, so we'll also do a little bit of comparison in the future. Again, probably towards the end of the week about, all right, a cylinder and a cone. It's actually pretty fascinating because they're closely related. And so we're going to use some water and pour it in and see how they're related once we get to that as well. Okay, so I also want to show you some of the wood figures. There's another prism, hexagon. You just look at the number of sides. These are the same ones. Another cylinder, cube, pyramid. There's a triangular prism. It's got a triangle on top and a triangle on the bottom. What if you have, let me pull this one. So we'll look at it. What does it think this is called?
Piece
Look
pizza.
at it.
Right
thicker than a piece of pizza.
triangular
That'd be a
prism.
good piece of pizza. Chicago.
Like Chicago style, right? Giordano's. All right, so yeah, you have a triangle as a base, but it's a prism, right? And so to find the volume, you find the area of the base times the height. It's the same thing as your desk. If you think about that, the area of your desk, right, is just the top of it. But the volume of it, you have to take into account the thickness of it. So you just take the area times the thickness. Okay? All right, so let's look at some more real life. I already talked about lunch today. What we got here?
Dodgeball.
Dodgeball, but a ball, some sort. But in geometry, what's it called? A sphere. That's right. And we'll have a whole volume formula for a sphere with circumference and radius and different things like that. No, it is not to play dodgeball in here.
I was gonna pass it.
This is a fascinating, I think, prism with a slice out of it, just to give you a view of it. And then what I'm going to eat my soup in today, cup of soup. Looks like a
Coffee cup.
cylinder, not coffee cup.
That's a big coffee cup.
Good job, Chase.
All right, I'm going to leave this stuff out. Oh, we got a couple more. One more. Cylinder, right? Man, this was full at the beginning of the year, Chase.
Cylinder.
And then we got another cylinder. This would be more of a prism, right? Like a rectangle.
Yeah.
All right, so hopefully you guys can see that the 3D or these type of figures are much more in the real world. And so a lot of what we're going to do some of the basic, all right, know the volume formula, but then we're going to apply it. How do you find the volume of a pool? How much water is needed to fill it up? How much water does your house use in its water heater, which is a cylinder? See what I mean? So it's very, very applicable to what we see. How much am I going to eat today? I'm only eating one.
Oh.
Not depends.
Can I have the other two?
It's already, yes, you're right. It is already. You guys can say hi to the. You're not on there. What's that? No! Don't touch my stuff, Evan. Okay, so let's see here. All right, so 18.1, volume of prisms and cylinders. I have an online book that I want you to look at, and I'll bring it up on the screen as well. Let's connect to my screen.
Wait, what are we doing?
Looking at the book, 18.1, section 18.1, page 925. 925. Yes. No. I'm going to have it up on the screen for you. You can look at your regular. Oh, yes. If you haven't turned in your extra credit, you're welcome anytime. Just put it on this stack up here. Okay. Staple is a good stapler. It goes through all 10 assignments. Okay. Volume of prisms and cylinders, 925. So here's the definition, the true definition. If you could, write those two definitions in your notes, just to help you remember it. Okay, write those definitions in your notes. Won't take long at all on this. A right prism and a right cylinder. Question, please. 925. Once you have that done, go ahead and turn to page 926. The volume of prisms and cylinder. It's one formula, but we're going to make it fit on both types of figures. Okay, so let's take a look at a prism first, and then we'll take a look at a cylinder. If you look at the screen, I'm also going to show you the way that I draw these. I'm going to make this a rectangular prism. So there's a rectangular prism. The dotted lines show that it's behind the view, so it gives a three-dimensional view of it. Look. Okay. As you look on the screen, you can see with my cursor, I'm outlining the volume is equal to capital B. The capital B represents the area of the base. So this would be the area of the base, length times width, and then we multiply it by the height. Now remember, the height here is the height of the prism. It's not the height of the base. You got to make sure you keep that straight, especially when we talk about a triangular prism. A cylinder. What's the area of a circle again? Anybody? Pi r squared. So I just substitute the pi r squared in for the capital B and multiply that by the height. And so that's my volume. Now remember, whenever I do volume, I have to do units cubed. Okay, you have, I'm going to give you 2 minutes. Let's put a timer on you. 2 minutes. Here's what I want you to do. You two, quiz each other. Don't look at your notes. I want you to memorize the volume of both a prism and a cylinder. So pair up. Evan, you can go, I don't care where you go. You pair up. You two guys, pair up. You might need to go threesies over there. Okay? Ready? Go. So make sure you know it. Make sure he knows it. Even if you do, make sure he knows it.
Prism, cylinder, pi r squared.
926.
Or this way equals
Pi r squared. It's the area of the base. Times the height. Times the height. Pi r squared, the area of the base, times the height. That's right, it's a circle. Sam, you got him? Make sure they got him. Kayla, you got him? What if it's a cube? Yeah, it's the same thing, except instead of L and a W, it's S, S, and S. Those are all the same. Yep. Okay, time's up as you can hear the timer. All right, we all got it? Sam, you got it? Evan, we good? All right, I'm not going to quiz you. You guys just quizzed yourselves. All right, let's move on. That's the volume of a prism. I do want you to look at, in the book, on page 927, that we are going to be doing real-life problems. We're actually going to do this tomorrow, more of these composite functions and real-life problems. But here you can see how to find the volume of an aquarium. Okay, of an aquarium on page 927. All right, so like I said, we'll be doing more of that tomorrow. Let's keep going. I do want you to look at page 928 and look at the problems on your turn, number 4 and number 5. It says, find the volume of the figure. As you can see, we've got 8 cubic units for the volume per little cube. Right there. That's an 8. So then all you have to do is count how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 times 8 is 88. Okay. Same thing on the next one. Each cube has a side of 2k. Find the volume would be 8k cubed. And then solve. Okay, right there it says oblique cylinder. Make sure you write the oblique prism and oblique cylinder in your notes. Page 928. You can see it right there. Here's, I like the, to draw these.
I don't like those.
One thing that you have to be careful with oblique is that the height, when you're finding it, is the height to the base, way down here. So it's like where the oblique figure is sitting on the table or on the desk. Okay, it's not the slanted height. Okay, here's a triangle. That's a triangular oblique prism. Okay. You guys see that on the screen? All right, last thing that we're going to do today, let's fill in the blanks on example B. Well, last stuff. Look at example B on page 929. Example B. Check for a little bit of understanding. Make sure we understand what we're doing. 929, example B. Fill in the blank. It says H is equal to blank S, 4S. Because the problem, the height of this oblique square base prism is 4 times that of the side length of the base. Everyone see the picture where it says 75? Okay. So to find the length of the S, we take the square root of 75. So the S is square root of 75. And then to calculate the volume and the height, we go 75 times 4 times the square root of 75. Fill in all those blanks. Okay? All right, now let's take a look at number 6 and number 7. You can see them on the screen. I'm also going to write them here. Volume is equal to the area of the base times the height. Okay? So, the area of the base in this case is pi r squared because it's a cylinder. That means the base is a circle. The radius is 12. And so we have 144 pi for the area of the base. And then the height, what did they say the height was? 45. So we're going to go volume is equal to 144 pi times 45. (144 pi times 45, as you can see, is already on the screen. 2357.5 inches cubed. Everyone good? All right, let's try. You try one. Check for understanding. Let's do number 7, right next to it. Let me give you a hint. This is going to be in terms of x. You don't know what the value of x is, and that's okay. Just leave it in terms of x. That's what it means to leave it in terms of x. X is in your answer. Could you distribute the 20x squared to both terms? Yes. Doesn't help you that much, but if you did, 20x to the third plus 40x squared, that's also acceptable as a solution.
Wait, it would be 40x squared.
Yes, because you take the entire thing, 20x squared, times 2. Yep. Okay. We good there? All right. Back to the book. Last thing we're going to do, one of your homework problems, just to get you on a good start here. Composite functions are things that we will talk about tomorrow to finish this off. Like I said, the real life examples. So look at page, I think it's 890, yeah, 932, sorry, 932. Take a look at number 1. It says the volume of prisms and cylinders can be represented with, of course, the area of the base times the height, where B represents the area of the base. Identify the type of figure shown and match the prism or cylinder with the appropriate volume formula. So we have A, B, and C. We just need to match them up. Look at letter A. V is equal to pi r squared times height. Which one would that match with? Somebody, anybody. The cylinder. So that would be the middle one. You can draw it or write it in, don't care. Look at letter B. Volume is equal to 1/2 base times height. What's that the area formula for? Triangle. That's right. So the one all the way to the right. And then the last one, of course, last one, length times width times height would be the prism. You can see on the screen all 3 answers are shown. Got it? Okay, good. Okay, so assignment, page 932. We're just going to do 1 through 8 today. Remember, we're going to add to this tomorrow. Okay, 932, 1 through 8. Oh, we just did number 1. What if on one of them they want you to find the area of a hexagon? Area of a hexagon. How would we find the area of a hexagon? Well, you got to think of it like this. Find the area of the triangle and then multiply it by 6. Okay? We're finding the area of a hexagon.